Hi, in this example, we're going to find the domain of a composition of two functions. We are given that f of x is equal to the square root of 2 minus x, and g of x is given to us as x squared minus x. The easiest way to do this is probably just to compose the two functions first. Therefore, we would have f of g of x. So we'll just replace every x in f with g of x, which is x squared minus x. So this becomes the square root of 2 minus x squared minus x. And this is equal to the square root of 2 minus x squared plus x. And if I just rewrote that a little nicer in descending order, we get negative x squared plus x plus 2. So here, with radical functions, specifically with even roots, so even roots means that there's a restriction on the domain, right? And that is where the radicand has to be positive or equal to 0. So we have to find where the radicand negative x squared plus x plus 2 is greater than or equal to 0. And if I multiplied through by a negative, here I would get, I have to be careful here, right? If I multiplied each side by a negative to get the leading term to be positive, this sign will have less than or equal to. And then we get positive x squared minus x minus 2 less than or equal to 0, because negative 1 times 0 is 0. I encourage you to multiply through by a negative so that leading term is positive, and it makes it easier when we're solving. So the next thing we have to do is we have to solve the inequality for x. So this means we'll have to go ahead and find the zeros of x squared minus x minus 2 and graph them on a number line and take test values. So here, if we factored this out, we would get x minus 2 and x plus 1 equal to 0, and therefore x would be equal to 2 or x would be equal to negative 1. And if I put this on a number line, here's negative 1 and here's 2. And I take test points, let's say negative 2, 0, and 3. I'm looking for the sign in this area for the inequality. In particularly, I'm looking for the numbers that are negative or equal to 0. So here in my number line, I'm going to be looking for the numbers that result in a negative number for my test value. I'm going to go ahead and use the factored form because that's a little easier when plugging and chugging. So here if I get negative 2 minus 2 and times negative 2 plus 1, again we only look at the sign. So negative 2 minus 2 would be a negative times negative 2 plus 1 would be another negative, which would result in a positive number. If I plugged in 0, I would get 0 minus 2 times 0 plus 1, and 0 minus 2 is a negative number, and 0 plus 1 is a positive number. And a negative times a positive is a negative number. Here, if I take the test value 3, I would get 3 minus 2 times 3 plus 1, which we could see that this is a positive times a positive, which results in a positive number. Now, the result here would be in between negative 1 and 2, because we were looking for only negative numbers are equal to 0. Here, I got a positive and a positive to the left of -1 and to the right of 2 respectively. This means that only in between -1 and 2 we will result in negative numbers, which means that this inequality would be untrue. So we want to make sure that any number we plug in has to be between -1 and 2, therefore f composed of g will always remain greater than or equal to 0. So this is why they mention that the domain is this closed interval from a to b, because it is in between these two numbers. So here the domain, therefore the domain of f composed of g of x is in between and including -1 and 2. So here for a would be the lower bound, which is -1, and the upper bound would be 2. And sure enough, lo and behold, these are the boundaries.